Hey guys, thanks for watching again. In these two last videos we will be wrapping up our project of our radio box for Microsoft Flight Simulator. As you can see, I've wired up everything together that we've done in the previous videos. And in this video we will be mainly focusing on the LCD screen and how to get the data from our game towards our screen. Most of the LCD we've gone over in the previous video, just like the rest of everything I wired up. But in this video it will be focused on the LCD, and in the next video we will wrap all the tiny little pieces of code we have together till we created one usable controller. So have fun. If you have a question, please leave them in the comments below and leave a like if you like it, and have fun. Hey guys, in this video we will be using my own connector to receive the data from our Microsoft Flight Sim 2020. It can be downloaded from bitsandroids.com/downloads, and I will put a link down in the description as well. It's the first link on that page. One thing you need as well is the Microsoftnet runtime framework, and it can be downloaded from the Microsoft site. I've linked it on the same page, and if you click on the direct download, the file will download instantly. Well, how does it work? Well, if you downloaded it, it will say it can be dangerous because it hasn't been downloaded a lot, which is quite obvious because I've just uploaded it. So I'm going to say I want to keep it. I'm going to open it. To use it, you actually need to unzip it. And then we can just run the exe. It's going to ask if it's safe. In my case, I trust myself, so I'm just going to say yes. If it asks you for the COM port to be used, you can go to Arduino, click on Tools, and see on which port your board is connected. So in my case, 13. I'm going to say 13. And the data gets passed quite instantly. And you have to leave this open, so don't close it. You can just minimize it, that's no problem. And if we go in game, it will pass the data. So if we change something, let's say change it lots of times, we can see it all coming in. It's saying error, error, because I have it multiple times open. Currently it only works if the game is running. So if you're past the press the screen button, you're in the main menu, you can start a program, or else it will just close itself. But that's just the current state. Let's say it's an early alpha, right? So it's a small little peek into what's coming. So please use it. If you have any questions or comments, let me know, and I will take them all in. If you have any suggestions on data you'd like to receive, please let me know as well, and I will try to incorporate it. So thanks, and have fun watching this video. Hi guys, as I've mentioned before, today we're going to be looking at putting everything together, what we've created in the last few videos. Perhaps you can see that on my board I've put everything together on a way too small board, but that's fine. Because our code, as you might see on my screen, is becoming quite large and big, I'm going to split this video up in two parts to make sure that it's comprehensible, and we're going to just go step by step through the process. The first thing we're going to do today is make sure that our data from our game gets passed to the LCD screen. So in this case, I will open the game so you can actually see that I'm not cheating. If we look at the frequency of the standby, we can see it changing. If I click it, I need to click it firmer. We see that we switch between kilohertz and megahertz. And we can swap the frequencies with a little button. There we go. See? And as you might have noticed, quite instant on the screen as well. Change the altimeter up. Oh, that's the max. Go down. And I haven't programmed the other buttons because I wanted you to be free to program it to whatever you'd like. Like if we change the heading, you can see actually how fast the LCD updates. So if we hold the button and I release, see there is a slight delay of a few, I don't even think it, perhaps a second, if you hold it for a longer time. But I think it's acceptable to actually use quite reliably, and the altimeter as well. I don't think I've actually, because I think if we go into the minus, oh, that's actually working as well. Kind of, no it isn't. But you shouldn't be going lower than sea level anyway. So that's it, what we're going to be looking at today. So if we first start with an empty sketch, and the reason I'm going to do this is because we have many loose pieces of code that we're going to put together, and I just want to make sure that we can organize things accordingly. But first we're going to be adding some new code. So, as you might remember from our previous video of the LCD screen, we need some libraries, which are the wire.h and the liquid crystal underscore I2C.h libraries. They can be added via manage libraries, and they can be found here. And if you want to add it, you can go to sketch, include library, and include the ones you've actually want to add. So once we've got that out of the way, we're going to initiate or declare our LCD screen. So liquid crystal underscore I2C. We're going to name it LCD is a liquid crystal underscore I2C. And it's located at the address of 0x27. This is by default. Most of the time, if you have a more complex setup on the board itself, this could differ. If this would be the case for you, please let me know in the comments and I'll tell you how to find the address of the LCD screen. In my case, as you might see, I've gone with a 4-row screen. I've used in my own model, I've used a 2-row screen. It's a bit up to you what you have available. I've destroyed my own 2-row screens by using plumbing flux for the soldering, and now they just burn through everything once they're on. So I'm not going to use those. I had this one lying around. So in my case, I'm going to say I have 20 characters per row and I have 4 rows. Usually the mostly common ones are 16 and 2, but you can alter that to whatever you'd like. I'm gonna paste the 16 and 2 in, just so you have a reference on how yours would look if you have 2 rows. And you could just uncomment this, so that double slash means that this row is a comment. So the code doesn't execute unless we remove this. And then we could just do the same if we had a 2-row and wanted to comment out the 4-row. So perhaps I'm going through this a bit faster, but that's because this part is already covered in the previous video. So if you have any questions about that, please watch the LCD video or else ask them in the comments and I will come back to you as soon as possible. So we're going to need some extra values. We're going to be getting a string. That's an input text. And I will explain everything in a second. But the input text is the string coming in from our program to our Arduino. We need a heading bug string. We're not going to do anything with it yet, so we're just going to declare it. Going to do altimeter pressure. Here we go. And we need a string for the autopilot altitude. So AP alt, I've named it. You could name it whatever you'd like. And a string is best described as a sentence or an array of characters. So it could be ABC, it could still be 0 to 5. But the only thing to note is if you do 0 to 5, you can't do plus 4, because that would become 0 to 5, 4. And it wouldn't become 29. So it's literally the text and not the value of the text. So we're going to remove this. If you type a string, you also need to look for the, how do you call these? Parentheses. Parentheses. So, I'm going to start a serial connection at 6900. Because we're using a Leonardo or Micro, whatever you have lying around, this value is actually not that important because it will use another kind of way to communicate via the USB. So it doesn't take the baud rate in account. Okay, and after we started it, we're going to do something new. We're going to say set timeout. We're going to set it at 50. And what this do is, by default, this is 1 second, and we're going to reduce it all the way back to 50 micro milliseconds. Correct me on that, but it says if we have something coming in, we're going to only take this amount of time to process it before something new can come in. If we leave this out and we put it on default, our values would only update every second. So you can imagine that if you change things very rapidly, the program is going to lag behind and it will just be one big mess. So we're going to say serial set timeout 50. You can tinker around with it a bit, because if you go too low, you have a chance that the data gets corrupted because it doesn't have the time to process it, while the new data keeps flushing in and everything gets clogged up. So that's something to keep in mind. You could also increase it if you think that it's getting unstable. Then you can go to 100. It's a feeling you have to create what works best and what doesn't. Okay, so oh, sorry, we still need to say, oh, no, we don't, but yeah, we need to start the LCD, sorry. So we're going to say in the setup block, lcd.init, so initiate, and lcd.backlight to turn the backlight on. And LCD refers to what we've set up here, this line. So it knows that this device needs to be initiated and this device needs to have its backlight on. Me personally like to have some mock-up data in it. So set cursor 0.0. And we're going to do lcd.print, let's say 124.850 and 29.292. And what this will do is that even though no data is coming in yet, it will display this line on our LCD screen just to have something to look at before it's populated with the real data. I'm going to say LCD set cursor 0,1. We're going to do lcd.print and we're going to do something similar. But this time we're going to say 198.400. These are just values I'm making up right now. And 35,000. Close the parentheses and press and close the line. So I'm sorry, the mailman came in and I had to run to the door. So I'm going to pick up where I left, and that's to see what happens. And I already uploaded the code, and as we can see, if we just have this block, it only displays our fake data right now. So that's exactly what we expected, so that's all fine. So we're going to do something in the loop. We're going to see what we can do to retrieve the data and to display it on the screen on a continuous state. So the first thing we're going to do is, I have an input text. So I'm going to do if, our serial is available. It's a function, so we're going to say the brackets, and it's bigger than 0. That's just going to check if something is actually coming in. So if nothing comes in, we're not going to do this block. I'm going to say input text is serial.read string. And yes, this is not the fastest way of processing data that comes in, but it works and it's the simplest. So in this case, I'm fine with it. We're going to do something to check what the size is of the string that is coming in. So I'm going to do input text. And because input text is a string, we can say dot length. And this will return a value of the number of characters in the string. So if we send A, the value is going to be 1. If we send AB, it's going to be 2. And that will just keep on counting up till we reach the value of the amount of characters. Now we have our input text, which we are reading from the serial. And we have the length of the string. So something we can do in programming is create a switch. And the switch is going to be determined by the length of the string. So in this case, an int. So we say switch according to this value. And perhaps it gets a bit clearer. So if we say case 1, do something. So if, it's a clearer way to avoid having to do if it's this, if it's that, if it's this, if it's that, else if. That would get messy quite easily. This is just a clean way to say, okay, we have a value. If it's 1, if it's 2, if it's 3, etc. We can create a much clearer view. So in my case, that's a bit, I know how my program works. So I know that if it's a 1, we have our heading bug. So remember up here we said a string heading bug. We didn't do anything with it. So now we're going to say our heading bug is 00 plus input text. So if only one value comes in, that means that our heading bug is 001, 002, etc. So we want to prefix it with a 00, and because it's a string, it will just paste it 00 plus the incoming text. And then we're going to say, I want to change the heading bug. Now we don't have a function yet that says how to do it, but we will make that in a second. And an important thing to do in a switch is say, okay, I'm done. End this case, no other cases. Just go back to the rest of your loop. And then we're all fine. So as I mentioned, we didn't have the change heading bug yet. So what we're going to do is we create a new function for that. So as we did in previous videos, we're going to say void because it isn't going to return anything. change heading bug. And in this piece of code, we're going to say set cursor. And then we're going to place it on the place that we want. So 0, 2 in my case. lcd.print heading bug. Now, what this is going to do, it's going to set the cursor at a place. Remember, I have 4 lines available. If you only have 2 lines, you can decide for yourself, okay, I want it on the, let's say the first line. So we're going to do 0, 0. And I want it instead of the altimeter. I'm going to do, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. But 0 counts as well. So I'm going to say 8, 0. And now it will replace this part. So that's something you have to figure out for yourself, where you want the information, depending on how much room you have available. So, quick recap. We say length. If the length is 1, the heading bug needs to be prefixed with 0, 0. So our heading bug was defined here. So now this has a value. So now this is 0, 0 plus the value we gave it. Then we say change the heading bug. LCD, put it on the place where I want to change it. And what are we going to place there? The heading bug that now has a value. So what we're going to do, if it's a 2, we're going to say heading bug is 1, 0 plus input text. So as you already see a pattern, if you only have 1 value, prefix it with 2. If you get 2 values, prefix it with 1, 0. And once again, we're going to change the heading bug and break out of it. And to keep it all nice and tidy organized, case 3. And you might have guessed this already. We aren't going to prefix it because it's going to be 3 numbers. Is input text. Now what would happen if we didn't prefix it is that every time it gets updated with, let's say, only 1 value, the previous values will remain on the screen because it doesn't override it with any data. So by just prefixing it, we make sure that the data line gets refreshed every time. Input text. And once again, we're going to change the heading bug accordingly. And we're going to break out of it. So this is actually all we need for the heading bug. We could already test it. Let's say upload. Now, if I run my program, let's see. It's going to ask me which COM port to use. So I'm going to say 13 apparently. And it's going to send the data. And as we see, it's 191 right now. And if we change the heading, it will change it accordingly. So that's the first one working already. And as we can also see, these are the values that get passed to a program. This will get sent to the serial port. And this way our Arduino knows what to display. So I will, in the description, I will put the link where to download it. It will be on my website. You can go to the bitsandroids.com. The link to the downloads page will be in the comments. Okay. So right now we've got our heading bug set up. Our fourth case, or at least 4 coming in, is going to be our altimeter pressure. So in this case, we're going to have a string that's called string A. Is a input text dot substring 0 till 2. Now, what does this do? In short, if you have the string coming in, altimeter pressure can be seen on the screen, the 29.92. We want the first two values, only the first two, so 2, 9, because 4 values are coming in, right? 2, 9, 9, 2. We only want the first two. So I'm going to say substring, like cut the string up, and I want this part. I'm going to say string B is input text dot substring, and now we're going to say 2 and 4. So what does this do? It splits the 2992 up into 9 and 92. So the first character is 0 up until the second, so 0, 1. The second one is 9 because we started 0. And our second part is from the second number, so 9, up until the fourth number. So that's 0, 1, 2, 3. And there is no fourth number, so just from 2 till 4. Now, once again, we're going to create a function that says, okay, change altimeter pressure. We're going to pass it a string A. And we're going to pass it a string B. And now we break out of it. Got a take a quick sip of my drink. Now, once again, we haven't created this function, so we go back up top. We're going to do something similar. We're going to create a function that doesn't return anything, so it's going to say void. And what are we going to call it? We called it change altimeter pressure. Change altimeter pressure. And this is going to request a string A and a string B. Now, I'm going to do the same as up top. lcd.setCursor. I'm going to place it at 8, 8, 0. So, once again, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we start at 0, so minus 1 is 8. And the first row is 0. Say lcd.print A. So the value A that gets passed to this function. Plus, we want a little dot in the middle. So the substring was just a 2, 9. We're going to add the dot. And now we're going to say string B. So the first part plus the dot plus the second part needs to be printed on the first row at the 8th character or the 9th, depending on how you count. Now, okay, we already have this covered. So this is actually going quite well. And the next one we're going to do, and yes, I know this is going to sound weird, but we're going to do 6. And the plain reason is, I don't know. I didn't create anything for the 5. So just decided to skip one, but we're going to work with it. The only thing we're going to do in case 6 and 7 is change the radio frequency. And it's going to change depending if it's the active frequency or the standby frequency coming in. So we could do everything in here, like split the string, like we did at the altimeter, but this time with 3 characters. But then we have to do the same twice. So we're going to create another function. So we're going to say change radio frequency. And we break it. We come back to this line in a second, because I'm going to first create the function, and then we go back to see what we need to pass to the function. Okay, these were quite straightforward. This one isn't all too hard as well, but it's a bit bigger. So we're going to say void, it isn't going to return anything, change radio frequency. Now, we want to know if it's the active frequency. So we're going to say active Boolean. So this can be true or false. So if you know it's true, then it's the active frequency. If it's false, it's the standby frequency. And we need the string of the full input. So if we get a string, like 124850, remember the dot is something that doesn't get passed. We add that ourselves. So we say string megahertz. So the first part is full input. Sorry, I was having a full input dot substring, and it's going to be 0 till 3. So 0, 1, 2, up until 3. So 1, 2, 4. Close it properly. And now we have a string kilohertz is full input dot substring. It's going to be 3 till 6. 3 till 6. So 0, 1, 2, 3. So from 3 up until 6. So 3, 4, 5, 6. There is no 6, but in this case, there is a 6 actually. That's the reason why we have the case 6, but we're not going to use that. Now, we have the strings. The only thing we need to know is if it's active. So if active, so if this Boolean is true, I'm going to say lcd.set cursor. Well, if it's active, we want it on the first line. So we're going to say 0, 0. And if it's not active, we say lcd.set cursor at 0, 1. So if it's active, first line. If it's the standby frequency, we want it on the second line. And then we're going to do lcd.print string megahertz plus the dot plus string kilohertz. So this string plus a dot plus this string will produce either on the first line, this entry, or the second line, depending if it's active. So in this case, we need to say case 6. Case 6, I have to peak, is the active frequency. And we're going to pass it to input text. We break out of it, and case 7 is change radio frequency false, and we're going to pass it to input text as well. And we're going to break out of it. So in our case, our system knows, okay, here we need to change the frequency. It is the active value. So we go up, change radio frequency. If it's active, set the cursor at 0. We split the strings and we print the splitted strings. And we do the same for case 7. The only difference part is where it's going to set the cursor. Now, it was a bit bigger chunk of code again, so we're going to just restart our program. Let's see, 13. And let's check if this is correct. 130.705 and 118.030. And if we switch it, we see that it switched places. So that is working fine. So now we can go on to the last view. And that's going to be the altimeter. This one. So, case. Once again, 8. And this time we're going to say, okay, we have our autopilot's altitude string. There's no value yet. So now I'm going to say if it's 8, I'm going to say autopilot's altitude is 0, 0, just like we did with the heading, but this time with the altimeter. Altitude, not altimeter, is input text plus input text substring 0 till 3. So it will always be 5 characters. The max is also 5 characters, also in game, so it can't go higher. So if, in our case, we split the string to 2 characters, 3 characters, sorry, 0, 1, 2. So we're going to prefix it with 0, 0. So it may sound strange because you have a string of 8 coming in, but that is just for our program to know how many, which value it is receiving. So even though this probably only has 5 numbers coming in, the string coming in is still 8 values long. And that's just a way to differentiate which value we're receiving. So it doesn't really represent the amount of numbers that is in the value. I hope that's a bit clear. So you shouldn't focus on the length that much, because that's just a quick and dirty way, to be honest, way of seeing which value we are receiving. I'm currently working on to change this to prefixes. So if the first number is a 1, for instance, and if the first number is a 2, instead of if the length is 1, 2, 3, to make it a bit more tidy. So autopilot altitude prefixed. And we're just going to create another function, change altitude, we're going to call it. I'm going to break out of it. So we don't have this function yet. I could just copy this, change altitude, go back up, change heading, change altimeter, change radio frequency. So create another function, void change altitude. It isn't going to take any parameters. And what does this function do? Well, because we have our AP alt, we can just say, here we go, lcd.set cursor. Let's see, in our case, that's on the first row. So 0, 1. So we're going to say 1. And it's going to start on the 8th character. So 8, 1, 2, 3, 4. Oh, sorry, 5, 6, 7, 8, 9, minus 1, because we started 0, 8. And we're going to say lcd.print AP alt. Okay, so we already have that function up. So the only thing left to do is create a case 9, where we say, you can just copy this, but we remove 1, 0. So prefix it with 1. We increase the substring, so 0 till the 4th character. And we have case 10, where we just say, copy this again. AP alt is input text, but comma, dot substring 0 till 6. So 10 characters are coming in, but only 6 of them 5 of them, 0, 1, 2, 3, 4, 5, are actually the values we're going to be using in our switch. So right now, if we upload this, we see our fake data, as is expected, because our program only passes data when something changes. Once we change something, here we see that the heading is coming in. Our altitude can be changed, and you can see the prefix. So if we lower this, so if we say we go less than 1000, it should prefix it with 2 zeros. So that is working. If it goes all the way up to 10,000, we shouldn't see any prefix if we did it correctly. Here we go. Okay, apparently I made a mistake. So it goes 0, 1, 2, 3, 4. So the cutoff point. And now you can actually see that an extra character is coming in. I don't know what character that is. It's just an extra filling to see which value is coming in. So we're going to change this to 5. If we upload this again, now if you start changing codes on the fly, I don't know if you already noticed, but it can take a minute or two before the game gets responsive again. That's something to keep in mind. Here we go. So right now, if we change the altitude, we can see that the prefix is working and nothing gets added in the end. Once again, because only when something changes, change the heading. And if we change the standby frequency, as you can see, it's actually it's snappier than I expected. Let's tell you that. It's first, when I started this project, this was slow. Data wasn't properly displayed. It was one big mess. But I think we've actually cleaned it up. And we already have something we can use. In the next video, I'm going to be showing, because this has been quite a long one for a small part, but essential part of a radio. So in the next video, we will be adding all our other codes to program the buttons, to program the rotary encoders. We already have the code in place, but we just need to make it fit inside this. So save this, use this already. You can actually even use this on a Arduino Uno or any other Arduino, if I'm correct, but then your baud rate gets, I'm not quite sure if it will work, but in theory it should work. So that's something we're going to be looking at. That will be coming up later this week, I think, perhaps tomorrow even. But for now, we can be using this. I would like to say thanks for watching. Leave a comment if you have any questions. I can understand that this was a bit more deep and detailed than the previous videos, so please let me know if you have any questions or I did go through it too fast. Leave a like if you liked it, and I'll see you on the next one. Thanks.